So good evening everyone and welcome to this lecture. This is lecture number 8 and we are going to probably finish off the series and parallel combination if possible. The last class we had seen how do we find out the series and parallel combination and how do we find out current and charges in different cases. Do we remember those questions? Yes or no? We had found out the charge appearing on all this. We had seen how quickly it can be done, and we must insist on getting the answers quickly because that is all that is going to matter in the final exam. Everyone understands this? Okay, now just to recap, because I don't know how much of you would remember, let me give you this question and I'm expecting an answer pretty quickly, and then we will move on to the other type of questions, which and how they are asked. So this is the question: in the following network, you have to find the potential difference across the 4.5 microfarad capacitor. So this is the first question that we are going to deal with. I need the answer quickly. Your time starts now. I'll give you 2 minutes.
6.6 microcoulomb.
6.6 microcoulomb. I don't know what you are answering, beta. You had to find out the potential difference, and now you're saying microcoulomb. So it's
Answer
difficult.
is
It's difficult for me to understand what you are answering. You have to find out the potential difference across this capacitor. So basically, you have to find out the potential difference like this V1. And now, how will I find the potential difference across this? To find the potential difference across this, it is divided in inverse ratio. Total potential is 12 volt multiplied by, I will find out the capacitance of this. This is 9. So 12 into 9 divided by total capacitance 9 plus 4.5, and you can easily solve this. The answer would be
answer.
8 volt. Should have taken so much of time to give me this answer? Huh? Don't know what is happening. Anyways, may God help you out. Now, this is one way of asking this question. The other way of asking this question is they would say that this point is A and they would say that this point is B. And then they would say that take the potential of point B as 0. Taking the potential of point B as 0. Tell me the potential of point C. How are you going to do this? I'll give you 1 minute to think about it. Remember, the question remains the same. The only thing is they're just asking it in a different way, and probably they're asking something else apart. They're asking the same thing in a different way. They are just using or mixing words in different ways. So now I've asked this question in this way. If the potential of point B is 0, what is the potential of point C? And you have 2 minutes, and please come back in the class with your heart and soul and not only your body. And, please solve this question. 2 minutes you have. Let me know the answer. So how are we supposed to find out the potential of this point? Now, if the potential of point B is 0, the potential of point A, which is here, the potential of point B is 0, the potential of point A becomes 12 volt. This point is also A. This becomes 12 volt. There are different ways in which you can do this. The potential of this point A is 12 volt. Now, what is the potential drop across the capacitor? We have already found the potential drop across the capacitor is 8 volt. So the potential has dropped by 8 volts. The potential has dropped by 8 volts. The potential has dropped by 8 volts. Potential at point A was 12 volt. Potential has dropped by 8 volts. Potential has dropped by 8 volts. Potential difference between A and C is 8 volts. So what is the potential of point C?
Good, sir.
Should not have taken so much of time unless and until I don't know what you all are doing. Should not have taken so much of time. Don't know what everyone is doing. So the potential of point B would have been 4 volts. This is one way of doing it. The other way of doing it is you could have found the potential drop across, you could have found out the potential drop across the next combination. You know that the potential drop across this one is 8 volt. So what is the potential drop across this one? The potential drop across this one must be 4 volt. This is point B, so this is also point B. The potential of this point is 0. So what is the potential of point C? It is 4 volt. So no matter how you would have done it, you would have ended with the same result. Do we understand this?
Yes, sir.
Are we everyone there in the class? I don't think that we are there in the class. Or
We
we
are
are there in the class and your mind is still somewhere else. Please bring it back in the class. Please. I request because these are simple questions. I had no plans of doing it. I just did it as revision part, and now what I'm finding is everyone is looking here and there, and I don't know where. This is shameful if you can't do this question. This is utter shameful. You should be ashamed of yourselves if there is any shame left in you. You should be ashamed. Anyways, this is the next question being taken from your favorite book, and I hope that all of us are in a sane mood and all of us are okay. I hope that I can get an answer to this one and that too quickly. So this is the next question that comes up. Question number 2. Consider the connection shown in the figure. Figure is there. Find the capacitance between A and B. Obviously, you can do it quite quickly. Find the charges on the three capacitor. Obviously, you can also do that. Taking the potential of point B to be 0. Find the potential of point D. I'm giving you 2 minutes to do this. I hope everyone does this. 2 minutes you have. Get me the answer of all the parts. You can do this, yes or no?
Yes, sir.
2 minutes. Wake up. Yes, tell me the answers for this. What is the equivalent capacitance? That is the first one. What is the
Sir.
equivalent capacitance? Yes.
6, sir.
6, sir. How did you get, sir? 12 and 4 are in series. That will give you, I think, 4. 4 and 2 are in parallel. Answer is 6. Well done. The answer for the first part is 6. Find the charges on the three capacitors. That was the next question. What is the answer for this one?
24, 6 is 24. On 2, it's 48.
On to this one. This is
48,
6
sir.
across 24. That is
Sir,
48.
96, 96 and 48.
This is 48. And the other one is 4. So it would be 96. Okay. Now we have woken up. Good. Good to wake up. 96, 96. Taking the potential of point B to be 0. So this point is 0. What is the potential of point D? Can I have the potential of point D? So basically they are asking you, what they are asking
16,
you
sir.
is the potential drop across the capacitor 6 microfarad. Yes or no?
Yes, sir.
How much is the potential drop? You have already found out the charge. Bacha, what is the potential drop? Charge is 96. Capacitance is 6. So the answer is 16 volt. Answer is 16 volt. Do we understand this or this has gone above our head saying bye bye? I'm
Understood.
going bye bye. I'm going bye bye. Please don't stop me. I'm going bye bye.
Understood, sir.
I'm really afraid of your understanding. Really scared of your understanding right now. I thought that you understood this last class, but as it turns out, I was wrong. I'm not getting answer as quickly as I was expecting, and that's a big what? That's a big thing that should not have happened. Anyways, I have to move ahead in life because life does not stop. 15 days. After 15 days, we are going to have our exams, and we must give it a good try. And I hope that we can keep our spirits high till that point in time. Here comes one more question, and I hope that I can get an answer quickly this time around. And remember, I'm a person of 48. No, not every day my age is increasing. It's still 42 right now, 42, 43, somewhere around that. I can solve this question without using copy and pen. And you are one third, not even one third of my age. Less than one third probably. Somewhere around 15, 16, one third approximately. So, this is the question. Take the potential of point B in the figure to be 0. Find the potential of point C and D. If a capacitor is connected between C and D, what charge will appear on the capacitor? You have 2 minutes to get me the answer. 2 minutes. So how are we supposed to do this? It's a very simple question. We don't have to use copy and pen. It has been given that the potential of this point can be taken as 0. And now, if I have to find the potential of this point C, basically what they are asking us is the potential drop across this 8 microfarad capacitor. Yes or no? Huh?
Yes, sir.
Yes, sir.
How do I find the potential drop across this 8 microfarad capacitor? I don't have to do much. I just have to see in what ratio it is getting divided. The total voltage, as you can see, the total voltage is 50 volts. So what do? I take 50 multiplied by, it divides in inverse ratio. So I multiply it by 4 and divide it by 12. Do we understand this? 4 plus 8, 12. Do we understand this?
Yes,
Sir.
sir.
So the potential drop becomes 50 by 3. That means the potential of point C becomes 50 by 3. Now I move on to my other capacitor. Let me, so again, I know the potential of point B. I have to calculate the potential of point D. How do I calculate the potential of point D? I just find the potential drop across the 6 micro, oops, wrong color, I hate wrong colors. You have to just find out the potential drop across the 6 microfarad capacitor. And how I'm going to do this? The total potential is 50. Total potential drop across the two capacitors is 50 multiplied by inverse ratio. So multiplied by 3 divided by 6 plus 3 is 9. And you will see that this is also 50 by 3. Now we come to the next part of the question. Both the potentials are same. They are equipotential points. So if I now connect any capacitor across C and D, how much will be the charge coming on that capacitor? Same point, same potential. So there will be no charge coming on this capacitor. Potential of point C and D are equal, and this combination becomes what it becomes, what it is known as, this type of combination.
Yes, sir.
This is the balanced Wheatstone bridge, sir. You can see, sir, this is 6, sir, this is 3, sir. That is 4, sir, that is 3, sir. This is 8, sir. This is 6, sir. That was our balanced V-stone bridge. And this is the concept of a balanced V-stone bridge. Do we understand this, or this has gone above our head saying bye bye, sir? Ho gaya, bahut ho gaya. Leave it. Leave us.
Yes, sir.
Understood.
Everyone understands this?
Yes, sir.
Okay. Now we come to the next category of questions, and the next category of question is questions on flow of charge. Flow of charge. And in this particular variety, they will ask you how much charge has flown from here to there or from there to here. And what we have to do in this question? Well, you just have to do what you have been doing. So instead of telling you anything, I again bring you a question, and again this question is from your favorite book. Here it comes now. Question number 4 or 5, whatever. Each capacitor shown in the figure has a capacitance of 5 microfarad. The EMF of the battery is 50 volt. How much charge will flow through AB? So whenever they ask you the question of charge flow, they will give you a direction of charge flow. So they're asking you how much charge has flown from A to B. Do we understand this?
Yes, sir.
There is a question on charge flow, they should give you the direction of charge flow, because if in this direction positive 50 flows, then in the opposite direction negative 50 flows. Do we understand this, or this has gone above our thing? Bye bye sir, ho gaya, chhod do, maaf kar do. Do we understand this?
Yes, sir.
Pakka?
Yes, sir.
Yes, sir.
So the EMF of the battery is 50 volt. How much charge will flow through AB if the switch is closed? So initially the switch is open. 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 Now the switch is closed. How much charge has flown? You will get
This is 100, sir.
2 minutes to solve this question and let me know the answer. So how are we supposed to do this? So what I have drawn are two conditions. The first condition is the initial condition, and the second condition is the final condition. In the final condition, I must have the switch closed. Now, initial and final conditions are drawn. Now, what I am going to see is a question of charge flow. How much charge has flown? So I must find out the charge appearing on each of the capacitors. So the first part of this question is, what are the charges when the switch is open? What are the charges appearing on each of the capacitors? Do we understand this? Yes or no?
Yes, sir.
Can you tell me what are the charges appearing on each capacitor when the switch is open? This is a simple question. What are the charges appearing on the three capacitors? It's a simple question. No one knows it? Yes, bacha? Hmm? There are three capacitors here. Can you tell me what are the charges coming on the three capacitors? Yes, bacha? Okay, I don't know. Well, if I talk about this capacitor, this would be positively charged, this would be negatively charged. What is the charge coming on this capacitor? Let me say the pink capacitor. What is the charge on the pink capacitor?
500 by 3.
500 by 3. Well done. So let me write it as 500 by 3. The pink capacitor has a charge 500 by 3. Can anyone tell me what is the charge on the blue capacitor?
250 by 3.
Okay, good. 250 by 3. This is positive and this is negative. Can anyone tell me what is the charge on the green capacitor?
250 by 3.
Plus minus 250 by 3. All of us agree on this? All of us understand this? Yes or no?
Yes, sir.
Pakka?
Yes, sir.
Okay. Now let us go back to the second condition. Now what happens when the switch is closed? When the switch is closed, this capacitor key, both the plates are connected to the same
How
point.
it is find it by 3, sir?
Yes, beta.
How would we get it is find it by 3, sir?
Find it out on your own. You will be able to find it out. Trust me. Try it. Two capacitors are in parallel. One is in series. You can find it out. Try it. If you can't find out this, we have done much more tough question than this, beta. It's a simple question. These two capacitors, blue and green capacitor, are in parallel. Then they are in series. You cannot find out the charge coming on each capacitor. You cannot find out the potential drop across each capacitor and multiply it by the capacitance. You can't do that, bacha. Can you do it now? Have we done any question before this like this where we had found out the charge on the capacitor, beta? Have you done it? Okay, I think the question is answered. Okay. Now, when I come to the second case, in this case, this capacitor actually gets shorted. Both the plates are connected to each other. So the charge on this capacitor in this case will be 0. Yes or no? Yes or no? Because the capacitor gets shorted and the plates get connected by themselves and the capacitor gets discharged. Now in this case, what is the charge coming on the other two capacitors? Can anyone tell me what will be the charge on this blue capacitor? Now only two capacitors are left. What is the charge on this blue capacitor?
One 125/2.
How much?
125/2.
125/2. How did you get 125/2? This is a battery of 50 volts. This 50 volts is applied across this 5 microfarad capacitor. 50 volt is applied across 5 microfarad capacitor. I think it will be 250. Yes or no? And this one would be 250. Do we understand this? Yes, Peter? Not able to hear you out.
Sir.
Yes, Peter? Not able to hear
Not
you
explain,
out.
sir. Explain. Sir, can you explain it once again?
What do you want me to explain, Beta? Which part you want me to explain? You cannot find out the charge on these capacitors. Which one you cannot find out?
How we got 250, sir?
How do we got?
250.
How do we got 250? Okay, very nice question. These are the two capacitors, Beta. Oops. That is the problem. You have not studied even a single bit in your school, in your home. And this is connected across a battery of 50 volts, Beta. And you cannot tell me how much is the charge coming on each capacitor. Then what do? I take you back to the first class where I was teaching you series parallel combination. Shall I take you there? Shall I take you there, bacha? To the first class where I was teaching you series parallel combinations? Yes or no? We cannot find out the charge on the capacitors. Shall I take you there to series parallel combinations?
Pi by 2.
No one knows how to find it out.
That's near.
That's it, sir.
Thank God. Thank God everyone understood. We all understand how series parallel combination. After 8 classes, we are able to understand series parallel combination. I am so pleased. Thank God for this. It has been a real privilege that you are able to understand series parallel combinations. Trust me, I'm so happy today. So, my happiness apart, the question still remains to be solved. We have to find out the charge flown through the switch. How are you going to find the charge flown from A to B? That still remains a question. That still remains a question. I think someone has given this answer wrong. Okay, I think no one would have understood this one also. I should do this one again. Have we understood this one? Have we understood how did I get this one? Everyone, have you understood this one? How did I get this? Yes or no? We understand this one?
Yes, sir.
Everyone understands this one? Yes or no?
Yes, sir.
Okay. How did I get charge in the initial case? These two are in parallel. These two are in parallel. 5 and 5 in parallel. How much it becomes 5 and 5 in parallel?
10.
10. Very good. Then this 10 and this 5 are in series. How much it becomes? 10 and 5 in series. How much it becomes? 10 and 5 in series. How much it becomes?
10 by 3.
10 by 3. 10 by 3 is the effective capacitance. What is the voltage of this battery?
And it 500 by 3.
How much is the voltage of this battery?
50, sir.
So what will be the charge coming on this capacitor? Do we understand?
Yes, sir.
How
100 by
much?
3, sir.
How much it is coming?
100 by 3.
500 by 3. Okay.
Sure, mama.
Then how will you get the charge on this capacitor and this capacitor? Both the capacitance are same. So how do I get the charge? How do I get the charge on the blue capacitor and the green capacitor?
By 3, sir.
Yes, beta?
50 by 3.
50 by 3.
250 by 3, sir.
Okay, 250 by 3. Okay, so we now have the charge on all the capacitors, but that was not the question. What was the question? Question was how much charge has flown from A to B. How do you find out how much charge has flown from A to B? You look at the initial condition and you look at the final condition. How much charge has flown from A to B, and you will understand it. How much charge has flown from A to B, and you will understand it. How much charge is from A to B, you will understand it. Yes. If you don't understand it in this way, you can understand. You can understand this in a different way. Okay, I'll give you 2 minutes. So how do you find out how much charge has flown? If you look at this plate of the capacitor, initially this plate was having plus 500 by 3 charge. Now if you look at this plate has 0 charge. So from there you can find out how much charge would have flown. This is one of the ways of finding out how much charge has flown. How much charge has flown? Initially, the positive plate was having 500 by 3 charge. Now, the plate is having 0 charge. What does that mean? That some negative charge would have flown from here to there. Yes or no?
Sir.
How much negative charge would have flown from one point to the other point?
500 by 3.
Minus 500 by 3 would have flown. Yes or no?
Yes, sir.
That is the answer. Minus 500 by 3 charge has flown from A to B. Do we understand this, everyone?
Yes, sir.
That is how we solve this question, where you have to find out how much charge has flown. We see what is the initial condition, we see what is the final condition, and then we calculate how much charge has flown from one point to the other point. Do we understand this?
Yes, sir.
Okay, can you do one question on your own based on this?
Yes, sir.
Okay, I will give you one question, and I hope, and this question will have okay, I'm just giving you 2 parts. If you can do those 2 parts, it is good enough. So this is the question. Again, it is taken from your favorite book, and I hope you can see this question. Yes or no?
Yes, sir.
Consider the situation shown in the figure. It's a very simple question. The switch is open for a long time. So the switch is open. Initially, the switch is open and then it is closed. Find the charge flown through the battery. You have to find out how much charge has flown through the battery when the switch is closed. What is the work done by the battery? Can you find out the work done by the battery? If you know the charge flown, You multiply it by V. Do you understand how to find out work done by the battery? So the only question is to find out the charge which has flown. I'll give you 2 minutes, 3 minutes. Take a deep breath. Look at what is asked. I've told you the procedure. The procedure remains same. Simple question. And I'll give you 2 minutes to give me an answer. Everyone can do this, yes or no?
Yes, sir.
Okay. So I made the question a bit larger so that you can easily see it. This is the question. Question number 3 or 4 or whatever it is. And I hope that you can get an answer quickly. So how are we supposed to do this? I have drawn these two diagrams. And what does these two diagrams represent? Well, they don't represent Alu Arjun. They represent initial and final condition. This is the initial condition. And this is the final condition. Now, in the initial condition, the switch is open. And in the final condition, the switch is closed. Now, when the switch is open, you can easily see the capacitors are in series, and you can find out the charges on this capacitor. The charges on the capacitor, let me call this as the pink capacitor. This will be plus, minus. To do both the capacitors are in series, so this will be CE by 2. Yes or no? No or yes?
Sir.
Then I have the green capacitor. On this green capacitor, this will be positive, this will be negative, this will be CE by 2. Do we understand this?
Sir.
Now I look at the final stage. In the final stage, what has happened is the blue capacitor is the only capacitor which is connected across the battery. The entire battery is there. So this is plus minus how much?
Yes, sir.
CE. And this green capacitor, actually it has been shorted because both the plates are now connected. It is not. What is the charge on the, because both the plates are shorted, it becomes 0, 0. Yes or no?
Sir.
It is very easy to see how much charge would have flown. You can look at any of the plates and see. If I just have a look at this plate, initially this plate was having plus C by 2 charge. Now the same plate is having plus C charge. So now I can understand how much charge has flown. In this direction, charge would have flown. Yes or no?
Yes, sir.
How much charge would have flown like this? Plus CE by 2. Do we understand this?
Sir.
So from this initial condition, we reach that final condition plus C by 2 charge has flown. Do we understand this, or this has gone above our head saying bye bye sir nikal gaya main to?
Understood, sir.
Now, what is the next part of the question? What is the work done by the battery?
E square by 2, sir.
Now you know the charge flown through the battery. Will the work done by the battery positive or negative? Is the work done by the battery
Yes, sir.
positive? Huh?
Positive.
Positive, because it is flowing in the direction of discharging. Well done. How much is that work done? Now we have woken up. How much is the work done? So first of all,
E
the
square
right
by
plus CE square by 2. Do we understand this?
Yes, sir.
sir.
We're gone above our head saying bye bye.
Understood, sir.
How many people have gone above? How many people it has gone? Everyone?
Yes, sir.
Everyone gone above heads?
Everybody understood, sir.
I'm scared of your understanding. Now, the next thing that we are going to do here is what else they can ask. What else they can ask in this question is the heat developed in the wires. Now, how are you going to find out the heat developed in the wires? Because that was a part of the question. So we'll write the next heading. Energy equation in capacitor circuits. So write the next heading, energy equation in capacitor circuits. Now this energy equation in capacitor circuit is going to give you the heat developed. Now, how is going to get you the heat developed? So remember this equation. Now, how does this equation is written? UI. What do you mean by UI?
Initial potential, sir.
Initial potential, initial potential energy. So you have to find out the initial potential energy. If there is one capacitor, one capacitor. If there is two, there is two. You have to find out the total initial energy of all the capacitors put together. Do we understand this?
Sir.
Plus, no. So in a circuit, you have some capacitor, they might have some energy. Now there might be a battery connected. So then we write plus work done by the battery. So battery is putting in some work. Battery might be doing in some work. Plus there might be some external forces acting on the system. Plus work done by the external forces. So basically what we are doing is applying work energy theorem. That would be equal to final energy, whatever is the final energy stored in all the capacitors, plus delta H out. So some part of energy will be going out in the form of heat. From here, you can find out how much energy is lost in the form of heat. Do we understand this?
Sir.
You understand it, but if I ask this equation tomorrow, you will forget it. Yes or no? Huh?
No, sir.
No, sir.
Note the time. Right now it is 2:25 p.m. and the day is 18th of December. And I'll ask you exactly whenever your class is tomorrow. I will ask you the same thing, and then I'll see how many of you remember it. Okay. Anyways, the only thing you have to forget is the habit of forgetting. That is the only thing that you don't forget. Okay. Now this is the equation that you have. This question had two more questions. This question had two more questions. What were the two more questions? What were those two more questions? Those two more questions are now coming up for you. Aniya Dekam. I hope you can see them. Yes or no? No, yes. Question number C and question number D comes up now. Find out the change in energy stored in the capacitor. Find out the heat developed in the system. So now I'll give you chance to whatever to show your talents. 2 minutes you have.
C square by 4.
One of the cash vouchers has proven okay. Okay, let us now first do things correctly and see. Let us first find out the initial potential energy, initial electrostatic potential energy. What is the initial potential energy? Tell me. How much is the energy in this pink one?
C square by 4.
Ah? You can find it out in many ways. Q square by 2C is the way. So how much is the energy coming in this one? Eh? CE square by 8. Yes or no? Huh?
Sir.
Pakka na?
Yes, sir.
Pakka? How much is the energy coming in this green one? Yes? No one knows the answer.
C epsilon square by 8, sir.
CE square by 8, sir. Thank God, sir. God is great, sir. What is the final energy in this one?
C
E
epsilon
square by 4.
What is the energy in this one? I again ask. Sometimes the cash voucher may not, I may have put a wrong code there. I again give you a chance to redeem
E
yourself.
square by 2, sir.
See, that was my fault. I had put the code wrongly. C square by 2. Okay. We also know what is the work done by the battery. What was the work done by the battery?
Square by 2, sir.
Plus C square by 2. Now I come and now I do everything that is needed here in this. Okay. How much is U initial? It is CE square by 8 plus CE square by 8. Yes or no?
Yes, sir.
What is the work done by the battery? CE square by 2. Yes or no?
Yes.
What is the work done by external forces? There are no external forces here.
Yes, sir.
So it is 0, 0. That must be equal to final potential energy. CE square by 2 plus energy given in the form of heat, dadang, padang, and whatever is left is the energy given out in the form of heat. So the answer is CE square by 4. Do we understand this?
Yes, sir.
What has gone above are they saying bye bye?
Yes, sir.
Girls, do we understand this or bye bye? Bye bye? Huh?
Understood, sir.
Bye bye?
Understood, sir.
Pakka no, sir?
Pakka, sir.
Your pakka is the problem, sir. So kacha is better than pakka. At least I know that is kacha, na? So that no, I will not. Okay, here comes this question. It's a big question, looks like a big one, but that helps us. Let me not give this one first. Let him. No, that was okay. That is better, in fact. Huh? So now, if now you can give the answer for this one, looks like a big question. This is again from your favorite book, which is giving milk right now at home. And please parcel that milk to me as well. I also like to drink milk from coming from SC Verma. I mean, that milk is really good. So please parcel me a copy of that milk through Zomato or something. And good. Whatever the number is, I have forgotten. The question is question number 45. For those people who don't like milk and would like to bring the book to the hostel and to the class to study. So for them, it is question number 45 somewhere in the exercise. A capacitor having a capacitor of 100 microfarad is charged to a potential difference of 24 volts. The charging battery is connected and the capacitor is connected to another battery of 12 volt with the positive plate of the capacitor joined with the positive terminal of the battery. So initial positive is again joined to the initial positive of the battery. Find the charges on the capacitor before and after connection. Number 2, find the charge flown to the battery. Number 3, work done by the battery, positive or negative. What is the magnitude? So everything is there in this question. Find the decrease in the electrostatic potential energy. Find the heat developed during the flow of charges after reconnection. So if you can do this question, if one of the cash vouchers may work, that means you have understood the entire concept of what is happening here. Is there any hope that we can get this question done?
Hi, sir.
Hopes are there.
Yes, sir.
See, the universe is running on hope that one day there would be a big bang again, and a new universe would be born. Okay, I'll give you 5 minutes because there are five. What five? Five questions, but I don't think a question. I think would hardly take 5 to 10 seconds to solve one question. So you should be able to do this question in 30 seconds, 40 seconds at max. But I'll give you 5 minutes. It looks like one of the cash vouchers has worked. Yes, my dear friends, which one has worked?
For first one, A, initially it's 24 charge and finally 1200, sir.
Can't hear you. Let me first draw the diagram so that all of us can understand it. So let me draw the diagram first and then we can discuss the question. So I have drawn these two revolutionary diagrams. This is the capacitor connected to 2 volt. Why I'm writing 2 volt? This is the capacitor connected to 24-volt battery. This is plus, this is minus. This is plus, this is minus. This is 12-volt battery. I must understand that this is the initial condition and this is the final condition. Remember that the positive terminal is still connected to the positive terminal. Okay, now let us go ahead and give the answer. The only capacitor is this pink one. Okay, so initially this is positive, this is negative. What is the charge coming on this capacitor?
2400.
2400 microcoulomb. So 2400 microcoulomb, that is correct. Now the green case is the case where this has been connected to a different battery. Now what is the charge? Remember,
1200, sir.
it would be 1200. So that is the first part of the question. We have found out. Find the charges flow on the capacitor before and after reconnection. Do we understand this, everyone? Yes or no? Huh? You understand this? Yes or no?
Understood, sir.
Understood, sir. Now the second part of the question is calculate the charge flown through the 12-volt battery. How much charge would have flown? How much charge would have flown?
Minus 1200.
You must also say the direction. So once I make a switch from here to here, once I make a switch from here to here, in this direction, 1200, no, sorry, minus 1200 would have flown. Yes or no?
Yes, sir.
Minus 1200 microcoulomb would have flown. Well done. The third part of the question is the work done by the battery or is it work done on the battery? Is the battery doing work or work is done on the battery? Yes.
On the battery.
Work is done on the battery. So work is done on the battery and it is going to come as negative. Yes or no? If work is done by the battery, it will come as positive. If work is done on the battery, it would come as negative. We all understand this? Now the next question is how much is the work? How much is the work done on the battery? Yes. No one solved this part? Huh?
Minus 14400 joules.
Minus 14400 microjoules. You have found out the charge which has flown. You just multiply this charge with this voltage. We understand this, yes or no?
Understood, sir.
Now let us find out the energy. How much is the initial energy? You can write this initial energy, UI. How much is the initial energy? It will be 2400 microcoulomb square divided by 2 into 100 microcoulomb. Yes or no?
Yes, sir.
Q square by 2C by microfarad. So remember, whenever you do this, you will always get the answer in microfarad, microjoule. So just tell me how much is it coming in microjoules. So you can find out that final energy. You can find out that initial energy. Yes or no? I don't have space. Okay, I can write it here. Not a problem. UI will be equal to 2400. So 2400 is 24 square is 576. And 2 zeros will get cut from the downwards, and then you will have divided by 2. So 576 divided by 2 will be 200 and something, right? 200 and kitna? 88.
288, sir.
288
Zero
100
joule.
microjoule. Yes or no?
Yes, sir.
288 28800 microjoules. Now let me come on this one. Final energy again, Q square by 2C. 12 square is 144 divided by 2 is 7200. 7200 microjoules. Am I correct? Is it coming like this?
Yes, sir.
You know the initial energy, you know the final energy. Now is the time to apply that equation. Can anyone tell me what is that equation?
It's
See, it's not even 30 minutes and no one remembers it. Yes,
Chipner,
you have lost the bet. UI plus
where this work done is equal to
work done by battery plus work done by external forces shall be equal to UF plus heat energy given out. We remember this?
Sir.
We now just need to put the equation, the values here, and we get our answer. So here I put 28800. Work done by battery is coming as minus 14400. Work done by external forces is 0. Don't worry about him. U final is 7200 microjoules. Micro is already going to come, so let me not. Then I can find out the heat given out in this process. Do we understand this, or this has gone above our head saying bye bye sir, ho gaya sir, enough sir, leave it sir, jane do sir?
Understood, sir.
Pakka?
Okay, sir.
Okay, then this one. Tell me fatak se.
6
So you can calculate it, na? Plus minus you can do, na? I can leave that part to you. So now this one, let's see who gives me the answer. Which cash voucher works in this case? Everyone understood the concept? So the last question of this category comes on your screen. Now again, it is from your same book. Question number 48, I guess. A 5 microfarad capacitor is charged to 12 volt. Good job. The positive plate of this capacitor is now connected to the negative terminal of the 12 volt battery and vice versa. Tan, tan, So now that thing is reversed. Calculate the heat developed in the wires, and I'll give you 2 minutes to solve this. Everyone is able to understand what we are doing here? Yes or no? Because I can't see you. I can only see one class, my favorite one. The other class is disappeared. Are we there?
We are there, sir.
Okay. 2 minutes you have. So, how are we supposed to do this? Well, we just know one way, and we will Continue
Plus
on.
144, sir.
Okay, I think that is the right answer. Let me just do it for you. So this is the capacitor initially. Let us say this is the initial condition. This is the 12-volt battery. This is the positive terminal. This is the negative terminal. Let me call this plate as A and let me call this plate as B. Just to differentiate the two plates so that I'm able to understand what was positive and what was negative before. Now, initially, let me call this capacitor as the pink one. This pink capacitor is connected like this. This will be the positive terminal and this will be the negative terminal. How much is the charge coming on this? 60. Do we understand this? Plus
Sir.
60 on this side and minus 60 on this side. Now, I have the next circuit. Now, things have been changed. In fact, the polarity has been changed. So, let me just change the battery here. So, I've changed the battery here. This is negative and this is positive. This is 12 volt. This plate still remains A. This plate still remains B. And let me call this as my green capacitor. Green capacitor now. This green capacitor, this plate becomes minus and this plate becomes plus. The charge is still 60 micro coulomb. Yes or no? No or yes? Do we understand this?
Sir.
See, everything is same, and I think this question is pretty simple compared to the previous one. Now, you just have to calculate the heat developed across the wire, but we will solve the entire question. Let me just find out the initial energy. What is the initial energy here?
364.
360 micro joule. Yes or no?
Yes, sir.
Okay, well done. What is the final energy here? It is also 360 microjoule. Yes or no?
Yes, sir.
Nothing changes. Okay. Now, initial charge is this, final charge is this. From initial to final condition, some charge has flown. Can anyone tell which charge, how much charge has flown and in which direction?
Minus 12.
How much?
12.
12. How much charge has flown from first condition to the second condition? First condition to the second condition, how much charge has flown?
0.
0? No. 0 is not the hero here. See. Initially, this was plus 60. Now it is minus 60. So 0 is not the hero here.
It's 120.
Minus 120 in this direction. Do we understand this? Yes or no? No, yes.
Understood.
The charge flown is minus 120. Now let us find out the work done by the battery. Is the work done by the battery positive or negative? It's positive only because charge is flowing in the same direction. Yes or no? Positive charge is flowing from positive to negative or negative charge is flowing from negative to positive. So work done by the battery is positive. How much is the work done by the battery? 1440 microjoules. Do we understand this?
Yes, sir.
It is
Sir.
positive. The charge flow is positive. Now I apply my legendary equation UI plus work done by battery plus work done by external forces is equal to UF plus heat developed. This and this will cancel each other out. Yes or no? This is 0. Yes or no?
Yes, sir.
So whatever is the energy given is actually whatever is the work done by the battery, it is actually going as heat. 1440 microjoules. Do we understand this? Now this has gone above our head saying bye bye.
Understood, sir.
Okay, then we have taken a lot of good steps today. In today's class, we have gone a bit forward. In the next class, we will see another type of questions where up till now the capacitors were initially uncharged. In some cases, they were charged also. plus 60, then it will become minus 60. We will continue and do this question, and we will see what happens if you connect more than two capacitors like this. Then what will happen? So that will be done in the next class. We'll try to wind it up. And then remember, the types of questions that are there in capacitors are more than what are the questions on register, because in capacitor they can ask you a large number of questions. So we'll continue with this question in the next class. I hope you enjoyed this class and you have understood something from this class. I am going to ask you this question. I am going to ask you this question tomorrow, because that's a challenge that I know that you will not remember and you will forget. So I'll see you tomorrow. Take care and God bless all of you.
Sir,
You don't forget it. Yes.
can you send previous 3 classes notes on Telegram?
Previous 3 classes notes on Telegram. I don't understand. What do you mean to say by this?
Notes for this of previous 3 classes.
Okay, I'll send it. I'll send you the entire capacity. Okay.
Sir. Thank you, sir.
Okay. Take care. God bless you.
Bye, sir.
Bye.